Hello and welcome everyone. I wanted to jump onto this new problem. Um, Basically, in here, you are going to be given an array consisting of n elements. You're going to be given an integer k2. Um, what you have to do is you have to print the minimum number of elements that you would remove, after which you get such an array which would always satisfy the following condition. What is the condition? The condition is that um, each and every adjacent elements, the adjacent elements absolute difference is always less than or equal to the number that is going to be given, which is the number k. You have to make sure that it follows this condition. Now, you can apply a couple of operations here. First of all, you can actually rearrange the elements, the initial elements that is given as an input array. You have the independence to do those stuff. And secondly, you can actually erase an element from an array too. Now, that erasing number, you have to minimize it. You have to rearrange the array in such a way that the erasing, or should I call it, the removing number, the removing element, should be as less as possible. And you would not want to do this operation much. What I mean by you would not want to remove that much amount of element. You would want to minimize the number of problems, in which in here it's called problems, but I will define it as you would have to minimize the number of elements that you can do in order to have such an arrangement which would satisfy the condition. What is the condition? The adjacent elements absolute difference, each and every adjacent position's absolute difference should be less than or equal to k. Now, first of all, what's the best way to solve this problem? First of all, you would want, if you were to reduce the number of erasing elements, you would definitely try to you would definitely try to rearrange the elements in the array in such a way that the difference is as less as possible, irrespective of whether it's greater than or less than k. Now, in order to do that, what's the best way to do that? What's the best way to make the elements come closer together such that the adjacent elements difference it can be as small as possible? If I do try to rearrange the elements, of course it's by sorting, because if you sort the initial array, what happens is the immediate next immediate next element in terms of numbers will be your adjacent members. That's exactly what happened, and that's why I took an example here. Let's say here we have an example. Of course, it's not initially sorted, but let's imagine that that's been given as one of the test cases. And what you would do is simply sort the array. Why it's important? Because if you sort it, the adjacent elements are the closest possible. They're the closest members that you can get. So it's you could call it a greedy way to think about it. You would sort the array, and then what? And then you would simply traverse the array, and try to see whether, try to lock on the number, whether there's a possibility, whether any adjacent position does not, does meet the condition or not, which means that you would check each and every position, and it would see if the adjacent differences, if the absolute differences of the adjacent elements is less than or equal to k or not. If it's less than or equal to k, then it's okay. Then what you would do is you would count the number of members so far that you have in your record. For example, if I do go through this position, I know that the difference, absolute difference between these two elements is less than or equal to, it's 1, which is less than 2, less than or equal to 2. So far I have the number, my answer is 2. So far my answer would be, the answer would be 2. Here the answer 2 means that the number of elements that will be left at the end of the day. And so what I mean by is that if you want to minimize the number of erasing elements, what that means is it's equal to, you would try to maximize the number of elements that are going to be left at the end of the day. So here, what this number actually defines here is that the number of elements that are going to be left at the end of the day. And the final answer would always be the total number of elements minus the maximum number of elements that are going to be left at the end of the day. What does this number actually signify? The number actually means that the minimum number of erasing elements, the minimum number of elements that you are going to be erasing from the array, right? So we're just thinking it in terms of the number of elements that are going to be remained at the end of the day. I want to maximize that such that when I subtract it from the total number of elements, I get the number which is the minimum number to reduce, or should I say, to erase from the element. So my goal is to maximize it. Now, I cannot simply, and now what I would do is I would simply traverse the array, and I would see if there is a condition, a position which does not satisfy the condition, which means if the, just like in here, as you can see, these two numbers, if I do an absolute difference, what am I going to get? 3. It's greater than 2. It's not satisfying the condition. What you would do in this scenario, would you take these elements, any of these elements? What would be the best option to do? The best option would be to start a new count from here. Why am I saying that? You are not actually going to erase it and do the operations. What I mean by is once there's a broken condition, it means the further elements are also going to be broken if you do compare it with this number. What I mean by is that because the numbers are sorted, if you erase it for any of the elements not satisfying the condition, what happens is that not only that element but also the elements that are previous to the erasing elements. For example, if I do remove 5 here, as it's not satisfying the condition, if I do remove it, what happens? 6 won't satisfy condition to 2. I cannot maximize it here. I'm gonna have to create a new group from here where that could be a possible answer. I'm gonna have to erase each and every one of it. Do you get my point? So that's exactly what I'm gonna do. Whenever I see a breaking condition, I will start my count from count equal to 1, meaning I will start a new possible answers condition. So what's going to happen from here? Okay, so far it's 1. Now I see the difference is less than or equal to 2. So the total number of members so far it's 2. Now, okay, difference is 1, so the answer is 3. And you can see 7, 8, 9, okay, less than or equal to 2. 4, so far 4 members have successfully reached the thing, and also 10 also satisfies the condition, so 5. Now in the meantime, I would also try to maximize. So definitely a max function is required, as my goal is to make as much elements as possible remained, which I will subtract it from the whole element, which eventually is going to give me the number, or should I call it the minimum number of elements that to reduce. So what my final answer is here. As you can see, I will try to maximize. So I get the maximum subarray that's going to be remained here is 5, meaning the total n minus 5. Here n is actually, I think it's 7. 1, 2, 3, 4, 5, 6, 7. So 7 minus 5 is 2. 7 minus 5 is 2. What does that mean? Minimum 2 elements I have to erase. What are those 2 elements? Those 2 elements are 1 and 2. If I do remove it, I have 5, 6, 7, 9, 10, a whole package. And 2 is the minimum number of elements that I had to remove. I could have done the other way around, but that would not have minimized the number of erasing elements. I could have said my answer is 5. Why? Because I could erase all of these packages, then I would have remained 1 and 2. That would satisfy condition. But when I would subtract it from the whole number, meaning 7 minus 2, I would have gotten 5, which would not have minimized the number of erasing elements. So I hope you do understand what I'm trying to say. You see, sorting the initial array actually solves sorting the initial array actually solves a complexity here. You could just think straightforward, and you would just create the possible subarrays. You take the maximum subarray in and erase the rest of them. And that's how you would think about this problem. If I do want to move for a coding explanation of it, you'll see that I'm taking the element, I'm sorting the array, and as you can see, I'm taking the difference. If it's managing the condition, I am just counting out, and if it's not managing the condition, I am just taking out the maximum possible subarrays that I have, and I'm just gonna delete and I'm just going to subtract it from the whole element to find out what's the minimum possible elements that have been erased. So yeah, that's all from my part. Thank you very much.